All right, so in this second example for chapter 10, we are comparing the grades for two populations of students. One that go to tutoring for help and the other that do not. All right, so we're looking at two populations of students, one that go to tutoring session for help and the second population that do not. And we picked out a random sample of 60 students, and we see that 26 students did not go to the tutoring session for help. Did go to the tutoring session for help, which leaves us with the remaining 34 that did not. So from this sample here, we computed what the average grade on an exam for these students were, and the summary statistics were as follows. For the 26 students that went to tutoring session, their sample mean was 81 with a standard deviation of 6 points, while the average grade for the students that did not go to the tutoring session was 74 with a standard deviation of 5 points. And what we would like to do is we would like to determine what the 95% confidence interval on the difference between these two groups of students was. So we would like to find a 95% confidence interval for the difference in population mean between the group of students that went to the tutoring session to help and the group of students that did not go to the tutoring session for help. All right, so before we start with the computation, we are comparing two population means here, right? So that could mean we could be using the non-pooled t-interval procedure, or we could be using the matched pair. So the first question I'd like to ask is, are these samples here independent or are they matched? Well, they are not dependent on one another, right? So there's, in each of these samples, there's 26 in one, 34 in the other, and these individual students are not linked to one another. So we have an independent sample, which means we're going to be probably using the non-pooled t-interval procedure. All right, so let's just set up a few terminology. Mu1, we're going to denote the population mean for students that went to tutoring session, and mu2 is going to denote the population mean for students that did not go to the tutoring session. And for those two populations here are the summary stats from their sample mean, the sample standard deviation, and the number in each sample. All right, so before we move on to the computation, I would like to address the point of whether the technical conditions are met or not. So as we mentioned, the sample is random and it's independent. The final question, if we want to see whether the technical conditions are met or not, is checking whether the sample was large enough or whether the population was normal. And we see that one of the samples here, the size is 26, so that sample is not large enough. And we only have summary statistics, which means we can't go look at the probability plot. Remember, if the probability plot was linear for the smaller sample, we could work under the assumption, right? It would be plausible that the sample was coming from a normal population. But since we have only summary stats, the third condition, the third assumption that we have a normal population or a large sample is not satisfied. So the only way our assumption is going to work is under the assumption that the test scores for the entire population are normally distributed. Right, so that's going to be our assumption here. And now, once we do that, to find the confidence interval, what we need to do first is find the degrees of freedom. And here's the computation for degrees of freedom. And when we do the computation, we get that the value is 22.77. And since we round down, the degree of freedom we're going to be working with is 22. Now, remember, we're working with a 95% confidence interval, which means our alpha is 0.05, alpha over 2 is 0.025, so we're going to go to our table, we're going to figure out what t of 0.025 is for degree of freedom 22, and when we get that the t value is going to be 2.074 in this case here. Now, once we know that, we can use the formula that gives us the endpoints for our 95% confidence interval, and the endpoints are, it's going to be the difference in sample means plus or minus this quantity here. So when I use plus, I get one of the endpoints, And when I use minus, I get the other endpoint here. So the plus or minus is going to give me 2 endpoints here. All right, so x1 bar, x2 bar, s1, s2, n1, n2 are all here in our summary stats right there. So we're going to take that, we're going to plug it in, and when we do that, we get that the confidence interval is from 3.98 to 10.02. All right, so as we mentioned in our video lectures earlier, when we are dealing with confidence interval of a difference, it is important to comment on whether the interval is entirely negative, entirely positive, and whether it contains 0 or not. So when we do this, we get that our interval is from 3.98 to 10.02. So in particular, we are going to note that the confidence interval, the 95% confidence interval for this case here, is all positive and it does not contain 0. All right, so what does this mean? Well, under the assumption that the test scores are normally distributed, remember we needed this assumption, we can be 95% confident that the students that went to the tutoring session scored on average between 4 and 10 points more on the exam than the ones that did not. All right, so at 95% confidence level, we can say that the students that went to the tutoring session scored on average between 4 and 10 points more than the ones that did not.